Gaze upon this colossal cosmic giant, NGC 4889, a supergiant elliptical galaxy drifting silently in the vast expanse of the Coma Cluster. From our vantage point, it appears as a serene island of light, a seemingly tranquil collection of stars holding its secrets close. But what if I told you that within this majestic celestial structure, astronomers have detected not one, not two, but 30 distinct phenomena that completely defy our current understanding of physics? These aren't just minor anomalies or measurement errors, they are fundamental contradictions to the laws we thought governed our universe. Every time we point our most advanced telescopes toward this galaxy, we uncover another piece of a puzzle that grows more bewildering with each discovery. This isn't merely about distant stars and cosmic dust. It's about confronting the very boundaries of human knowledge and realizing how much we have yet to learn. We're about to embark on an extraordinary journey through the weirdest, most mind-bending cosmic occurrences ever documented in one of the universe's most massive galaxies. Imagine black holes behaving in ways that should be impossible, unexplained energy signatures erupting from nowhere, and gravitational anomalies that twist space-time itself into knots. These aren't science fiction scenarios, they're real, recorded events happening right now, millions of light years away. Each of these 30 strange phenomena challenges not only what we know about galaxies, but forces us to reconsider the fundamental principles of reality. What makes NGC 4889 such a hotbed of cosmic mystery? Why here and why now? The answers might reshape our understanding of the cosmos forever. This video is your invitation to explore these breathtaking discoveries alongside the scientists who are racing to decode them. We'll dive deep into the data, unravel the theories, and confront the possibilities that lie just beyond the edge of human comprehension. You'll witness cosmic events so bizarre they seem to defy logic, and you'll come away with a renewed sense of wonder about the universe we inhabit. So settle in, open your mind, and prepare to journey into the heart of one of space's greatest enigmas. What we find there might just change everything we thought we knew. At the very heart of this galactic giant lies its first and perhaps most profound mystery, a supermassive black hole of such staggering proportions it redefines the word massive. We've named this phenomenon the impossible black hole, and the title is earned. Current estimates place its mass at an almost incomprehensible 21 billion times that of our Sun. To even begin to visualize that scale, consider that the supermassive black hole at the center of our own Milky Way, Sagittarius, a star, is a mere 4 million solar masses. The beast at the core of NGC 4889 is over 5,000 times larger. Its event horizon, the point of no return where not even light can escape its gravitational clutches, is so vast it could easily engulf our entire solar system, from the Sun to well beyond the orbit of Neptune, not just once but multiple times over. This isn't just a cosmic vacuum cleaner, it's a gravitational abyss of epic proportions, a void so powerful it warps the very fabric of space-time around it. And herein lies the paradox that has astronomers utterly baffled. According to our current models of galactic evolution and physics, a black hole of this immense size should be an engine of pure chaos. Its gravitational influence should be so overwhelmingly disruptive that it would prevent stars from forming, tear existing solar systems apart, and essentially sterilize the galactic center, creating a volatile and barren region. Yet, when we observe NGC 4889, we see something entirely different. The galaxy is stable. It's a calm, smooth ellipse of ancient stars, showing no signs of the violent turbulence such a behemoth should inevitably cause. It's like discovering a perfectly still pond with a whirlpool at its center large enough to drain an ocean, yet the water's surface remains placid and unbroken. This contradiction forces us to ask a fundamental question. How can this impossibly massive object exist without completely dominating and destroying the galaxy it calls home? The answer might lie in secrets of dark matter, unknown states of equilibrium, or principles of physics we have yet to even imagine. But the sheer mass of the central black hole is only the beginning of the strangeness. As we turn our attention to the broader galactic canvas, we encounter our second phenomenon, and it is one that defies all conventional explanation: ghostly gamma-ray bursts. These are not your typical cataclysmic cosmic explosions. Gamma-ray bursts are normally the most violent events in the universe, the final death cries of massive stars or the violent mergers of ultra-dense neutron stars. They are fleeting, incredibly intense flashes of the highest energy light, usually lasting from mere milliseconds to a few minutes at most. The bursts emanating from within NGC 4889 are something else entirely. They are sporadic, unpredictable, and most baffling of all, unusually prolonged. Instead of flashing and fading in an instant, these events can persist for hours, sometimes even days, emitting a steady, ominous glow of gamma radiation that simply should not be possible based on our current models of stellar physics. It's as if a cosmic switch is flipped on, and instead of a sudden explosion, we get a sustained, high-energy hum from the depths of the galaxy. The mystery deepens considerably when we try to pinpoint the source of these eerie emissions. Meticulous analysis of the data points the origin to what appears to be utterly empty space. These are not regions densely packed with stars, nebulas, or any other objects known to produce such energetic outbursts. They are vast, dark voids between the stellar populations of the galaxy. It would be like hearing a persistent, powerful siren blaring from the exact center of a completely silent, empty desert. There's nothing there that could possibly be producing the sound. Astronomers are left scratching their heads with no known celestial event or object to blame. The leading theories are just as strange as the phenomenon itself. Could these be the signatures of an entirely new class of celestial object, one that is invisible to every other part of the electromagnetic spectrum except for gamma rays? Perhaps they are evidence of dark matter particles annihilating each other in massive, unseen clouds, a process that would release tremendous amounts of energy. Or maybe, and this is a concept that pushes the boundaries of theoretical physics, these prolonged bursts are the result of quantum activity within the fabric of space-time itself, a leak from a hidden dimension into our own. Each burst detected is a direct challenge, a signal from the cosmos that our understanding of how energy is created and released on a galactic scale is still profoundly incomplete. Just when we think we've begun to grasp the strangeness of this galaxy, we uncover a phenomenon that challenges our understanding of the universe's most fundamental, yet invisible component, dark matter. This brings us to our third great mystery of NGC 4889, an anomaly so profound it forces us to question the very nature of this elusive cosmic substance. Throughout the cosmos, dark matter is understood to form a vast spherical halo around galaxies. This halo is the hidden scaffolding upon which the entire visible structure is built, its immense gravitational pull acting as the glue that holds everything together. In every other galaxy we've ever studied, this dark matter distribution is smooth, massive, and predictable. But in NGC 4889, the rules seem to have been rewritten. Advanced gravitational lensing studies, where we observe how the galaxy's gravity bends and magnifies the light from even more distant objects behind it, have revealed something astonishing. The dark matter here is not arranged in a standard diffuse halo. Instead, it appears to be concentrated into distinct, colossal ring-like structures. Imagine the rings of Saturn, but on an incomprehensibly larger scale, woven from the fabric of the universe's most mysterious material and encircling the entire galaxy. These are not solid rings, of course, but incredibly dense, toroidal, or donut-shaped concentrations of dark matter, regions where its gravitational influence becomes intensely focused. This bizarre configuration has a dramatic and observable effect on the space around it. These dark matter rings act as powerful cosmic lenses, but their unique shape warps the fabric of reality in an unusual way. As light from galaxies billions of light years behind NGC 4889 travels toward us, it passes through these rings. Instead of creating a single, slightly magnified image or a classic Einstein ring, these dark matter structures twist and amplify the light to produce multiple, highly distorted, and often duplicated images of the same background galaxy. It's like looking at a distant street lamp through the bottom of a grand, intricately cut crystal glass. The single source of light is fractured into several bewildering and beautiful images. Astronomers are seeing triple, quadruple, and even quintuple visions of the same cosmic object, all arranged in strange, arcing patterns around NGC 4889. This phenomenon presents a monumental puzzle for cosmologists. How did these rings form? What physical process could possibly sculpt dark matter, which barely interacts with itself or normal matter, into such precise, stable structures? Current models of dark matter behavior, primarily based on the concept of cold, slow-moving particles, struggle to explain how such dense, ring-shaped congregations could emerge and, more importantly, persist without collapsing or dispersing. Some theorists are now suggesting that the properties of dark matter itself might be different here, perhaps possessing a type of internal interaction or force we have not yet discovered. Others propose that the gravitational influence of the galaxy's impossible central black hole might have somehow shepherded the dark matter into this impossible formation, like a shepherd corralling invisible sheep into a circular pen. Each distorted image we observe is not just a pretty picture, it is a data point in a grand experiment, forcing us to reconsider the fundamental properties of the substance that makes up the vast majority of matter in our universe. Now we venture into what is perhaps the most philosophically jarring and controversial of all the anomalies observed in this galaxy. The potential signature of quantum entanglement operating on a scale so vast it seems to tear the rulebook of physics to shreds. This is our fourth phenomenon, and it centers on a baffling communication between particles that appears to ignore the universe's ultimate speed limit, the speed of light. To understand why this is so revolutionary, we need to grasp a fundamental rule. In our everyday world and in classical physics, nothing can travel faster than light. This cosmic speed limit is the bedrock of Einstein's theory of relativity, a principle that has been tested and confirmed countless times. If you want to send a signal, a message, or any form of information from one point to another, it must take time to cross that distance. Even a command sent to a probe on Mars takes minutes to arrive. This law ensures that cause and effect are always separated by a delay, preserving the logical flow of the universe. Yet, in the strange subatomic realm governed by quantum mechanics, there exists a bizarre phenomenon called entanglement. When two particles become entangled, they share a single quantum state, linking their fates inextricably. The truly weird part is what happens when you measure one of them. If you separate these two entangled particles and then observe the state of one, say, its spin direction, the other particle, no matter how far away, instantly assumes the corresponding state. This change is immediate. It appears to happen with zero delay, even if the particles are on opposite sides of the galaxy. Einstein famously rejected this spooky action at a distance, arguing that it violated relativity because it suggested information was traveling faster than light. For decades, physicists have performed entanglement experiments here on Earth, confirming this spooky connection over distances of many miles. But the consensus has always been that this is a fundamental property of the particle's shared origin, not a method for sending actual information or signals faster than light. It's a correlation, not a communication. The observations from NGC 4889 throw a monumental wrench into this settled science, researchers analyzing specific streams of particles emanating from the galaxy have detected pairs that exhibit the telltale statistical correlations of quantum entanglement. That alone would be astounding, but the real shock is the estimated separation between these particle pairs. Based on their trajectories, these partners appear to be thousands of light years apart. According to every law we know, maintaining a coherent quantum link across such a mind-boggling distance should be utterly impossible. The constant interactions with other particles and fields in the intervening space should have decohered the system, collapsing the fragile entangled state almost immediately. The implication is staggering. It suggests that within this galaxy, the quantum world doesn't just operate on the scale of atoms. It might be woven into the fabric of the cosmos itself, enabling connections that defy our understanding of both space and time. If these findings are confirmed, they don't just point to new physics. They suggest an entirely new layer of reality where the concepts of here and there are fundamentally interconnected in a way we can scarcely imagine. The debate this has sparked is fierce. Skeptics argue it must be a flaw in our interpretation of the data, an unknown astrophysical process mimicking the signature of entanglement. But proponents see a glimpse of a deeper truth, a universe far more deeply and mysteriously connected than we ever dreamed. Deep within the swirling expanse of this galactic enigma, astronomers have tuned their instruments to a different kind of signal, one that pulses with a rhythm both mesmerizing and deeply perplexing. This fifth phenomenon introduces us to the celestial musicians of NGC 4889, the singing neutron stars. Neutron stars are the collapsed, ultra-dense cores of what were once massive stars, and they are typically known for their incredible regularity. Many act like cosmic lighthouses, spinning rapidly and beaming out pulses of radio waves with a metronome-like precision so reliable we can use them as clocks to navigate the cosmos. The neutron stars in this particular galaxy, however, are playing a different tune altogether. They do emit powerful, rhythmic pulses, but their behavior is anything but predictable. Their timing is off. The pulses arrive with a steady beat for a while, then suddenly, and for no discernible reason, they stutter, speed up, slow down, or even skip a beat entirely before locking back into a new, different rhythm. It's as if a flawless orchestra of perfect clocks has been infiltrated by jazz musicians who occasionally improvise, disregarding the sheet music and following a score only they can see. This isn't a simple malfunction. The changes are complex, almost musical in their variation, earning them the nickname the Singing Stars. What could possibly cause such a fundamental disruption to the most reliable timekeepers in the universe? The leading hypothesis points directly to the galaxy's immense and unusual gravitational environment. We must remember that NGC 4889 is home to that impossible central black hole and those mysterious rings of dark matter. The fabric of space-time here is not smooth and uniform as it is in quieter galactic neighborhoods. It is likely warped, rippled, and contorted by these colossal, unseen masses. As a neutron star moves through this distorted landscape, the subtle changes in gravity could be tugging on its structure, minutely altering its insane rotation speed and thus the timing of its pulses. Imagine a perfectly tuned drum being carried across a room where the gravity changes from spot to spot. The drummer's arm would be pulled this way and that, causing the beat to waver unexpectedly. Another, even more speculative theory suggests a direct and bizarre interaction with the galaxy's dark matter. What if these dense neutron stars are actually accumulating a halo of dark matter particles around themselves? As this invisible cloud gravitationally interacts with the star's own immense density, it could create a dragging effect, a form of cosmic friction that steals a tiny amount of rotational energy and manifests as these strange timing glitches. We are essentially listening to the stars struggle against a force we cannot see, their rhythmic songs being subtly corrupted by the universe's most elusive material. Each erratic pulse is a data point, a clue that we are missing a fundamental piece of the puzzle regarding how matter and gravity behave under the most extreme conditions imaginable. Yet the core of this galaxy holds a secret even more elusive than singing stars or entangled particles, a phenomenon that redefines stealth in the cosmos. We now turn to the sixth great mystery of NGC 4889. Colossal jets of superheated plasma erupting from its heart that are almost completely invisible. In a typical active galaxy, such jets are brilliant beacons, powered by the intense gravitational energy of matter falling into a central black hole. They blast out across millions of light years, glowing fiercely in radio waves, X-rays, and other forms of light. They are some of the most energetic and visible structures in the universe. The jets pouring forth from this galaxy are the polar opposite. They are phantoms. Our telescopes, tuned to every wavelength from radio to gamma rays, detect almost nothing coming from these vast streams themselves. They are dark, emitting little to no radiation across the entire electromagnetic spectrum. We only know they exist at all because we can see their ghostly handiwork, like watching invisible currents in a pond by observing how they push and distort floating leaves. Astronomers have detected these jets by their profound impact on the thin gas that permeates the space between the galaxy's stars. Vast bubbles and ripples are being carved out of this intergalactic medium, shocked and heated by the passage of something immense and powerful that our instruments simply cannot see directly. It's the astronomical equivalent of feeling a powerful wind on a perfectly calm, silent night. You know a force is moving, but you can neither see nor hear it. This presents a monumental puzzle. What could possibly be powering such energetic yet dark outflows? The sheer scale of these jets indicates they must be driven by the galaxy's central supermassive black hole, but their behavior is completely anomalous. One leading theory suggests these are jets in a failed state, lacking the necessary raw material to fully form. Perhaps the accretion disk, the swirling maelstrom of matter falling into the black hole, is unusually starved of gas and dust. Without a dense, bright stream of material to energize, the jet might be launching a mostly pure, invisible beam of magnetic energy and a thin soup of fundamental particles, which only becomes apparent when it slams into the much denser gas far away from the galaxy's core. Another, more radical idea posits that the jets are not made of normal matter at all. Could they be composed of something exotic, like theorized dark matter particles or some unknown form of energy that simply does not interact with light in any way we can detect? Their ability to travel vast distances without dispersing or shining suggests properties we have not yet catalogued in the cosmic ledger. These invisible jets are more than just a curiosity. They are a direct challenge to our models of how black holes feed and how they influence their surroundings. They force us to admit that the most energetic processes in the universe might be happening right in front of us, hidden in plain sight, revealed only by the subtle distortions they impose on the visible world. Now we approach a phenomenon that seems to bend the very rules of existence, where the universe's clock ticks at different speeds in neighboring regions of space. Scattered throughout the vast expanse of NGC 4889 are areas astronomers have termed time dilation hotspots. These are not locations you could point a telescope at and see a visible distortion. Instead, their discovery came from meticulously analyzing the rhythmic flickering of certain cosmic beacons. By observing the pulses of variable stars and the brilliant, steady light from distant quasars shining through the galaxy, scientists noticed something profoundly strange. In these specific pockets, the light signals appeared to be stretched out, slowed down, and dramatically redshifted in a way that couldn't be explained by simple distance or motion. The only plausible explanation was that time itself was passing more slowly within these zones relative to the rest of the universe. It's a direct validation of Einstein's theory of general relativity, but on a scale and with an intensity that is utterly unprecedented. We expect some time dilation around massive objects. It's why a clock on a GPS satellite runs slightly faster than one on Earth's surface. But the effect detected here is orders of magnitude greater. We're not talking about microseconds of difference over years. We're talking about a discernible, measurable slowing of time that would be obvious to any observer. Imagine two identical spaceships, one orbiting safely outside a hotspot and the other venturing inside. To the crew on the outside ship, their counterparts on the inside would appear to be moving in extreme slow motion, their movements and speech drawn out like a record played at the wrong speed. Conversely, for the crew inside the hotspot, the external universe would appear to be accelerating wildly, with stars blinking in and out of existence in moments and galaxies evolving in a frantic blur. This isn't science fiction, it's the real physical consequence of gravity's power to warp the fabric of space-time. What could possibly generate such extreme temporal distortions? The immediate suspect is, of course, the galaxy's immense gravitational field, sculpted by its impossible central black hole and the mysterious rings of dark matter. The sheer concentration of mass in certain areas could be creating gravitational wells so deep that they drag on the flow of time itself. However, the distribution of these hotspots doesn't always perfectly align with the predicted locations of the highest mass, suggesting something else might be at play. This has led to a more speculative yet thrilling possibility that these areas are not just gravitational anomalies but perhaps intersections with other dimensions. Some theoretical models of string theory and brane cosmology suggest our universe may be a membrane floating in a higher dimensional space, and where these membranes touch or warp, the fundamental laws of physics, including the flow of time, could be altered. The implications of these time warps are as profound as they are bewildering. For cosmologists, they offer a unique natural laboratory to test the limits of general relativity under conditions we could never hope to recreate on Earth. For philosophers, they challenge our very conception of time as a universal constant, suggesting it is a malleable, local phenomenon. If you could somehow survive the immense forces at work within one of these hotspots, you could, in theory, experience the passage of a single minute while centuries fly by in the outside universe. These regions are cosmic time capsules in the most literal sense, and their existence forces us to confront a universe far more dynamic, fluid, and strange than the steady, predictable clockwork we perceive from our small corner of it. Orbiting this galactic giant like a fleet of spectral ships is a population of satellites so faint they border on the invisible, challenging our very definition of what a galaxy can be. These are the phantom dwarf galaxies, our eighth profound mystery, and they are cosmic paradoxes made manifest. In every other galactic neighborhood we've studied, dwarf satellite galaxies are commonplace. They are typically small, faint collections of stars, but they are still visible, their light a testament to the star-forming processes that once occurred within them. The dwarfs circling NGC 4889 are something else entirely. They are detected through their subtle gravitational influence, their pull on the motions of visible stars and gas. But when we point our most powerful telescopes directly at their coordinates, we see almost nothing. They are vast clouds of dark matter, possessing the gravitational signature of a full-fledged galaxy, yet they contain a number of stars so low it defies all logic. They are the ghosts of galaxies, the outlines of structures that never fully awakened. This presents a direct and formidable challenge to our established models of how galaxies form. The prevailing theory, known as the lambda-cold dark matter model, provides a robust framework for understanding the universe's large-scale structure. It posits that galaxies grow within halos of dark matter, with this invisible scaffolding pulling in normal matter, gas and dust, which eventually cools, condenses, and ignites into stars. For a dwarf galaxy, we expect a certain ratio. A specific amount of dark matter should correspond to a predictable and significant population of stars. These phantom dwarfs completely shatter that expectation. They have all the dark matter, the gravitational weight of a galaxy, but they are missing nearly all of the stars. It's as if you found the foundation, framework, and outer walls of a massive skyscraper, but upon entering, you discovered only a single, dimly lit room inside a structure designed to hold thousands. Why did star formation fail so catastrophically in these satellites while it flourished in their parent galaxy? Astronomers are investigating several compelling and equally strange possibilities. One leading theory points to the incredibly hostile environment of the Coma Cluster itself. In this densely packed region of space, the intergalactic gas is searingly hot. It's possible that when these dwarf galaxies were first forming, the intense heat of this surrounding plasma prevented their own pristine gas from cooling down and collapsing to form stars. They were essentially stillborn, frozen in their infancy by a cosmic climate too extreme for stellar birth. Another, more dramatic idea involves the immense power of NGC 4889. The invisible jets and intense radiation pouring from the central black hole, even if faint, could have swept through these nascent dwarfs billions of years ago, physically blowing away their star-forming gas and effectively sterilizing them, leaving behind only their dark matter skeletons. The existence of these phantom galaxies, however, might be the key to unlocking one of astronomy's most persistent riddles, the very nature of dark matter itself. Their sheer abundance and bizarre composition provide a unique natural experiment. If dark matter is cold and collisionless, as our best models assume, meaning its particles move slowly and rarely, if ever, interact with each other, then it should form these dense, clumpy halos exactly as we see. But if dark matter had any other properties, if it were warm, meaning its particles moved faster, or if it could interact with itself through some unknown force, it would smooth out these small-scale clumps, preventing the formation of such numerous, dense dwarf halos. The fact that these phantom dwarfs exist in such numbers around NGC 4889 is actually a strong point of evidence for the standard cold dark matter model. They are the precise small-scale structures it predicted must exist. Their failure to form stars is then a separate issue, a story about the complex and often violent astrophysics of their environment, not a failure of the dark matter model itself. In their profound emptiness, these ghostly galaxies are speaking to us, affirming the hidden architecture of the cosmos while simultaneously presenting a stunning mystery of their own. Now we turn our attention to a concept so theoretical it sounds like it's ripped from the pages of a science fiction novel. Yet it might hold the key to some of the strangest gravitational signals ever recorded. This is the ninth phenomenon, the potential presence of cosmic strings vibrating within the very fabric of NGC 4889. To understand what a cosmic string is, you have to picture the universe in its earliest, hottest moments, just a fraction of a second after the Big Bang. As the cosmos expanded and cooled, physicists believe it may have undergone a series of phase transitions, much like water freezing into ice. And just as ice forming on a pond can develop cracks and fissures, the fabric of space-time itself may have crystallized with flaws infinitely thin, unimaginably dense filaments of pure energy left over from creation. These are cosmic strings, theoretical one-dimensional defects thinner than a proton, yet so massive a single inch of one could weigh more than Mount Everest. Their existence has been predicted for decades, but they have never been conclusively observed. The reason we're looking for them here, in this particular galaxy, is due to a series of peculiar gravitational wave signals that have been picked up by observatories like LIGO and Virgo. These ripples in spacetime didn't match the classic chirp of two black holes or neutron stars merging. Instead, they were persistent, faint, and continuous hums, almost like a sustained musical note, all traced back to the general direction of the Coma Cluster. The frequency and nature of these signals have led some theorists to a breathtaking possibility. What if one or more of these primordial cosmic strings are threaded through NGC 4889, and the gravitational waves we're detecting are the result of them vibrating, oscillating, or even intersecting and snapping like enormous galactic guitar strings. If such strings do exist within the galaxy, their influence would be nothing short of profound. A cosmic string's immense density creates a gravitational field unlike any object we know. It doesn't pull matter inward in a spherical field, but rather creates a conical, razor-sharp warp in space around it. This would have a dramatic effect on the evolution of the entire galaxy. As the string vibrates and moves, its intense gravity could act as a cosmic seed, a linear filament around which the first stars and gas clouds preferentially formed billions of years ago, essentially providing a ready-made skeleton for the galaxy's development. This could help explain the galaxy's immense size and smooth, elliptical structure, as matter would have flowed along these invisible gravitational guidelines. Furthermore, the strings could be the hidden architects behind some of the other mysteries we've already discussed. Their unique gravitational distortion might be shepherding dark matter into those impossible ring-like structures, or their vibrations could be subtly influencing the erratic timing of the singing neutron stars. The potential to explain multiple anomalies with a single, elegant, albeit exotic, theory is what makes this idea so compelling to physicists. We may be witnessing not just a galaxy, but a galaxy built upon the cosmic scars of the universe's very first moments. Nestled within the swirling expanse of this galactic giant lies a region of profound silence, a cosmic quiet zone that has astronomers utterly perplexed. This is our 10th phenomenon, the energy void. To understand its significance, we must first appreciate the constant, gentle rain that fills every cubic centimeter of our universe, the cosmic microwave background radiation. This is the fading afterglow of the Big Bang itself, a nearly uniform sea of microwaves that permeates all of space, a fossilized echo of the universe's fiery birth 13.8 billion years ago. It is the universe's baseline hum, and it is everywhere, except, it seems, in one particular region of NGC 4889. When scientists mapped the intensity of this background radiation across the galaxy, they discovered a vast spherical area where the signal drops dramatically. It's as if a giant, invisible sponge is suspended there, soaking up the microwave photons, leaving behind a chilling void in the ambient energy of space. This isn't a small dip. The dimming is significant and localized, suggesting something within that specific volume is actively interfering with this most fundamental energy field. The immediate, most conventional explanation points to the presence of an immense reservoir of extremely cold gas. If a cloud of molecular hydrogen, for instance, were vast and frigid enough, its atoms could absorb the microwave photons, preventing them from passing through. The scale required, however, is almost beyond belief. We're talking about a cloud so colossal it could dwarf entire star systems, a structure of cold, dark gas on a scale we've never before witnessed. Yet, even this extraordinary idea runs into problems. Such a massive concentration of normal matter would have other, obvious gravitational effects on surrounding stars and would likely be visible through other means, such as silhouetting against background light or emitting its own faint radio signatures. So far, no such corroborating evidence has been found, leaving the cold gas hypothesis intriguing but unproven. This failure of conventional answers has opened the door to far more exotic possibilities. Could this void be a signature of something entirely new? One compelling theory involves a hypothetical form of exotic matter. We know that dark matter, which makes up the bulk of the galaxy's mass, doesn't interact with light, but what if there are other, even stranger particles that do? Certain theoretical constructs, like actions or other weakly interacting particles, are predicted to have the ability to convert microwave photons into other, undetectable forms of energy. A dense cluster of such particles could effectively act as a one-way filter for the cosmic background radiation, creating the precise kind of shadow we observe. Perhaps the most mind-bending possibility connects this void directly to the galaxy's ancient origins. NGC 4889 is an ancient elliptical galaxy, likely formed through the monumental collision and merger of multiple large galaxies in the very early universe. Such a violent and energetic birth process might have left behind permanent scars in the fabric of space-time. The energy void could be a relic of that formation, a kind of cosmic eddy or standing wave where the density of space itself is different, a fossilized bubble from an era of unimaginable energy that now manifests as a region of profound stillness. It stands as a stark reminder that the universe's oldest structures may harbor secrets from their creation that we are only just beginning to sense, a silent echo of the chaos that gave them birth. But our journey into NGC 4889's weirdest phenomena now takes us from the grand scales of time and gravity to the realm of the profoundly small, where a discovery could rewrite the textbooks on one of nature's most fundamental forces. We now turn to the 11th great mystery, the hunt for magnetic monopoles. To understand why this is such a monumental deal, we need a quick primer on magnets. Every magnet you've ever held, from a simple fridge magnet to the most powerful neodymium kind, has two poles, a north and a south. If you break a magnet in half, you don't get an isolated north and an isolated south. You get two new, smaller magnets, each with its own north and south pole. This duality is a fundamental rule of electromagnetism, a law so ingrained that we've never found a magnetic particle with just a single pole. Theoretical physicists, however, have long speculated that such particles, called magnetic monopoles, could and should exist. Their existence is a key prediction of several grand unified theories, ambitious models that attempt to describe the electromagnetic, weak, and strong nuclear forces as a single, unified force that existed in the extreme energy of the early universe. Finding a monopole wouldn't just be about discovering a new particle. It would be a direct window into the conditions a fraction of a second after the Big Bang, confirming that the forces of nature were once truly united. So why are we looking for them in this specific galaxy? The answer lies in strange and persistent anomalies detected in the galaxy's vast outer halo. Sensitive instruments have mapped the magnetic fields permeating this region, and the patterns they reveal are bizarre. Instead of the expected, smooth loops of magnetic force lines that connect north to south, there are areas where the magnetic field lines appear to simply end. They don't connect back to an opposite pole, they vanish into nothingness like countless threads cut by a pair of cosmic scissors. This is the tantalizing signature that something with a single magnetic charge, a north without a south or a south without a north, could be present, distorting the local magnetic environment in a way that only a monopole could. The immense gravity and unique history of NGC 4889 provide the perfect breeding ground for such exotic relics. It's hypothesized that the galaxy's formation, through the violent merger of countless smaller galaxies over billions of years, could have acted as a cosmic fisherman's net, trawling the depths of space and concentrating these rare particles from a much larger volume of the universe into its own halo. Furthermore, the sheer mass of the galaxy and its central black hole could be generating the kinds of immense energies needed to create monopoles anew, even today, in processes we don't yet understand. Each anomalous magnetic field reading is a siren's call to physicists, a hint that we are on the verge of a discovery that would fundamentally alter our understanding of the universe's blueprint. Leaving behind the theoretical hunt for fundamental particles, we encounter a cosmic event that is both spectacularly violent and deeply puzzling in its apparent disregard for the rules. This is our 12th phenomenon, the case of the recurring nova, a stellar explosion that refuses to follow the script. In the standard cosmic playbook, a nova is a well-understood, though dramatic, event. It occurs in a binary star system where a white dwarf, the dense, Earth-sized corpse of a sun-like star, is locked in a gravitational dance with a living companion star. The white dwarf's intense gravity strips hydrogen-rich gas from its partner, which accumulates on the white dwarf's surface. Over time, this layer builds in pressure and heat until it triggers a runaway thermonuclear explosion. The star can brighten by tens of thousands of times in a matter of hours, appearing as a new star in the sky to ancient observers. Crucially, this explosion only blows off the accumulated surface material. The white dwarf itself remains intact, and the process can begin all over again. These recurrent nova typically have predictable intervals, erupting every few decades or centuries as the accretion process steadily reaches its critical point. Now meet the maverick in NGC 4889. Astronomers have identified one specific nova system within the galaxy that has erupted on at least 5 separate occasions. That in itself isn't unusual. Recurrent nova are known. What is utterly bizarre is the complete lack of any discernible pattern in its behavior. The intervals between its outbursts are wildly inconsistent, fluctuating from as little as a few years to as long as several centuries, with no rhythmic cycle to be found. Even more confounding is the energy output. Each eruption releases a dramatically different amount of energy. One might be a relatively faint flash, while the next could be a cataclysmic event orders of magnitude more powerful, as if the stellar engine is being tuned by a capricious hand each time it runs. This erratic behavior throws a wrench into the well-oiled machinery of our accretion disk models. A white dwarf fed by a steady stream of material from a normal companion star should behave like a geyser on a reliable timer, not a volcano with a random number generator for an eruption schedule. So what could possibly be causing this stellar unpredictability? One compelling theory points to the nature of the companion itself. Perhaps it is not a typical, stable star, but something far more unusual, a highly variable star itself, one that undergoes massive, unpredictable pulses in its own output. Imagine trying to fill a bucket using a hose where someone else is randomly turning the water pressure from a trickle to a torrent and back again without warning. The rate of accretion onto the white dwarf would be thrown into chaos, leading to these wildly irregular build-ups and subsequent explosions. A more exotic and frankly thrilling possibility involves the galaxy's pervasive dark matter. We've already seen how this mysterious substance seems to be configured into strange rings and may even influence other processes. What if this particular binary system is orbiting through an especially dense knot of dark matter? Theoretical physicists have proposed that certain types of dark matter particles could become trapped within the intense gravitational field of a white dwarf. If these particles are of a specific kind, they could annihilate upon contact with each other, releasing a tremendous burst of energy deep within the star's interior. This would act as an invisible trigger, prematurely igniting the hydrogen layer at completely random times and with varying intensity, depending on how much dark matter had recently accumulated. The nova would no longer be solely powered by the fusion of accreted gas, but also by this shadowy external power source, creating a hybrid explosion that defies all standard classification. This single rebellious star, flashing on and off like a faulty cosmic light bulb, challenges our understanding of stellar life cycles and raises the incredible prospect that the invisible majority of matter in the universe might be playing an active, violent role in the lives of the stars we can see. Now we turn to perhaps the most speculative and controversially thrilling of all the phenomena observed in this distant galaxy, a set of signals that forces us to ask a question we rarely pose in professional astronomy. Are we looking at something that was built? Scattered throughout the vastness of NGC 4889, our most sensitive infrared telescopes have detected something that defies easy classification. It's not a single point of light or a diffuse cloud, but a series of faint yet distinctly geometric patterns. We're talking about precise, repeating hexagonal and grid-like signatures etched into the infrared glow of the galaxy. Structures that, at first glance, bear an uncanny resemblance to something engineered rather than born of natural chaos. The immediate and most sensational interpretation points to the realm of science fiction becoming science fact, the potential evidence for alien megastructures. The most famous hypothetical construct is the Dyson sphere, a colossal shell or swarm of orbiting objects designed by a Type II civilization on the Kardashev scale to completely encapsulate a star and harness the entirety of its energy output. The infrared excess we detect could be the waste heat from such an unimaginable project, the byproduct of a cosmic engine radiating away the energy it cannot use. Given the sheer number of stars in a galaxy this size, the idea that at least one could host a civilization advanced enough to embark on such a project is not, strictly speaking, impossible. The geometric patterns could be the signatures of multiple such constructs, or even something beyond our current imagination, vast communication arrays, propulsion systems, or art installations on a galactic scale. The mere possibility sends a shiver down the spine, suggesting we might not be alone in a universe that is not just stranger than we suppose, but stranger than we can suppose. However, extraordinary claims require extraordinary evidence, and the scientific community rightly approaches this idea with intense skepticism and a rigorous search for natural explanations. The first and most likely culprit is an unknown but entirely natural astrophysical process. We are observing this galaxy across millions of light years, and our view could be distorted and shaped by phenomena we have not yet encountered. For instance, could the gravitational lensing effects of those dark matter rings be warping the infrared light from background objects or from clumpy star-forming regions in a way that creates the illusion of geometric symmetry? The universe is full of complex magnetic fields and shock waves from supernova. Perhaps the interplay of these forces with vast clouds of interstellar dust is sculpting that dust into temporary, ordered shapes that we are only now seeing for the first time. The galaxy's impossible black hole could be powering energy flows that interact with its environment in ways that produce regular rather than chaotic patterns. There is also the ever-present possibility that we are being fooled by our own technology. Instrumental artifacts, though diligently searched for, can sometimes create phantom signals. The intricate optics and sensors of space telescopes like the James Webb or the retired Spitzer are immensely complex. A subtle misalignment, a previously unknown type of pixel crosstalk, or even the impact of a cosmic ray on the detector could, in theory, generate a repeating pattern that isn't actually out there in the cosmos. Before we can claim a revolution in our understanding of life in the universe, we must first exhaust every possible prosaic explanation, a process that is ongoing and painstaking. What makes this mystery so captivating is that it sits at the perfect crossroads of science and wonder. It doesn't allow for a simple answer. The natural explanations are compelling and probable, but they are not yet proven. The artificial explanation is breathtakingly profound, but it remains a last resort. This tension is the very engine of scientific discovery. These enigmatic infrared patterns, whether they turn out to be the signatures of novel physics or something even more incredible, serve as a powerful reminder of why we look up. They challenge our arrogance, reminding us that a galaxy as old and as massive as NGC 4889 has had billions of years for processes both natural and perhaps otherwise to unfold in ways we are only beginning to perceive. Deep within the swirling dust lanes of this ancient galaxy, we find a phenomenon that allows us to literally look into the past, not through theory or simulation, but by observing light that has traveled on two separate journeys across millennia. This is the 14th wonder of NGC 4889, the hauntingly beautiful light echoes. The concept is as elegant as it is powerful. When a star ends its life in a titanic supernova explosion, it floods its immediate surroundings with a brilliant, fleeting pulse of light. This initial flash races outwards in all directions at, of course, the speed of light. But if that light, on its direct path to our telescopes, encounters a vast, distant cloud of interstellar dust, something magical happens. Some of that light is reflected like a flashlight beam hitting a mirror in a dark room. This reflected light must now travel a longer, indirect path to reach us. The result is that we see the main event, the supernova, brighten and then fade as expected. But years or even decades later, we see a second ghostly apparition, a ring or arc of light that appears to expand outward from the location of the long-dead star. This is not a new explosion, it is an echo. It is the light from the original cataclysm, finally reaching us after its detour, allowing us to study the same event all over again. In most galaxies, these echoes are rare and precious opportunities, giving astronomers a second chance to analyze the spectrum of a supernova and determine exactly what kind of star exploded and what elements it forged in its final moments. But in NGC 4889, the light echoes are not just helpful tools, they are messengers delivering profoundly confusing news. By analyzing the specific wavelengths of light in these delayed glows, scientists have been able to reconstruct the properties of supernova that occurred centuries ago. Several of these historical explosions do not match the profile of any known type of supernova. We have well-defined categories: type Ia from white dwarfs, type Roman II from collapsing massive supergiants, and so on. The echoes from this galaxy, however, reveal explosions with bizarre chemical signatures, unusual ratios of elements like calcium, titanium, and oxygen, and energy outputs that are either far too weak or far too sustained for their proposed class. It's as if the stellar graveyard here is filled with tombstones inscribed in a language we cannot read, pointing to types of stellar death we have not yet dreamed of. These anomalous echoes suggest that the stars which lived and died in NGC 4889 eons ago might have been fundamentally different from those we see elsewhere. Perhaps they formed from a primordial soup of elements that was unlike the mix found in younger galaxies like our own, leading them to evolve down strange evolutionary paths and explode in ways that are no longer possible in the modern universe. Each expanding ring of light is a time capsule, preserving the final seconds of a star that does not fit into our tidy classifications, forcing us to expand our understanding of how stars can live and die. Now we descend even deeper into the subatomic heart of the unknown, to a realm where the very canvas of reality is said to churn and boil. This brings us to our 15th phenomenon, a concept so fine-grained it defies direct observation, yet its potential effects here are writ large across the cosmos: the stirring of quantum foam. To grasp this idea, we must venture to the very limits of known physics. Quantum mechanics tells us that at the tiniest possible scale, the Planck length, the serene vacuum of space is not empty and smooth. Instead, it is a seething, turbulent ocean of energy. Virtual particles blink in and out of existence in a frantic dance, and the fabric of space-time itself is theorized to be frothy and chaotic, constantly fluctuating between different geometries. This frenetic activity is what physicists call quantum foam, the fundamental foam from which all reality is built. Under normal circumstances, these fluctuations are immeasurably small, their effects vanishingly tiny. We could never hope to see them. Their existence is a prediction of the mathematics that seek to marry quantum mechanics with general relativity, a goal that has remained stubbornly out of reach for a century. However, NGC 4889 may be providing a unique natural laboratory. The staggering gravitational pull of its central black hole and the intense warping of space-time around it could be acting as a universal magnifying glass for these minuscule effects. The theory suggests that in such an extreme environment, the microscopic frothiness of space could be amplified, its turbulence made large enough to have a measurable impact on something we can actually see: light. And this is where the mystery takes a tangible form. When astronomers train their most powerful telescopes on the distant quasars whose light passes very close to the galaxy's core on its way to Earth, they notice something subtle yet persistent. The images are not perfectly sharp. there is a faint additional blurring, a softening of the finest details that cannot be fully explained by atmospheric interference, instrumental limitations, or even the known effects of gravitational lensing. It's as if the light is passing through a kind of cosmic haze, a frosted glass window on the universe that slightly scrambles the information it carries. This anomalous blurring is the exact kind of signature that theorists would expect if the quantum foam of space-time were being agitated and enlarged by the galaxy's immense gravity. The foam's chaotic nature would slightly jostle the photons traveling through it, creating a minute but detectable degradation in the clarity of the images we receive. If this interpretation is correct, the implications are nothing short of revolutionary. For decades, physicists have been searching for any experimental evidence that could bridge the gap between the world of the very large, governed by gravity, and the world of the very small, ruled by quantum mechanics. The blurry images from this galaxy could be the first ever observational hint of quantum gravity, a faint fingerprint of the foamy structure of space-time left on the light that has journeyed through the most extreme environment we can observe. It offers a potential way to test theories like loop quantum gravity or string theory that predict such a foamy nature, not in a multi-billion-dollar particle collider, but by observing the natural experiments conducted by the cosmos itself. Each slightly smeared photon is a messenger from the edge of physics, suggesting that the void of space is not a passive stage but an active, turbulent participant in the story of the universe. Yet for all its immense gravitational presence, NGC 4889 presents us with a profound and deeply counterintuitive cosmic accounting error, one that brings us to our 16th enigma, the case of the missing baryons. Baryonic matter is the stuff of our everyday world, the protons, neutrons, and electrons that make up every star, every planet, every gas cloud, and indeed every one of us. Based on the galaxy's truly staggering total mass, which is dominated by its immense halo of dark matter, we can make a very precise prediction of how much of this normal, baryonic matter it should contain. The ratio of dark to normal matter in the universe is a well-measured value, and for a galaxy this massive, the amount of stars, gas, and dust should be correspondingly enormous. The numbers are almost too big to comprehend, pointing to a reservoir of normal matter that should be blindingly bright, filling the galaxy with a dense, brilliant fog of countless stars and glowing gas. But when we add up everything we can actually see and detect the light from all its stars, the emission from its nebulae, the faint glow of its hot gas, we come up drastically short. A significant fraction, potentially up to half, of the baryonic matter that our models insist must be there is simply missing. It's as if a billionaire's financial ledger showed assets worth billions, but a physical inventory of their vaults and properties revealed only half that amount. The money has to be somewhere, but it's not where you expect to find it. This isn't a small rounding error. It's a fundamental discrepancy in our inventory of the universe's most basic building blocks within one of its largest structures. So where could it all have gone? One compelling theory suggests the matter isn't truly missing, but has been rendered nearly invisible to our current telescopes. The galaxy's incredible gravitational pull, amplified by its location in the dense Coma Cluster, could have stripped vast quantities of gas from its outer regions over billions of years. This material wouldn't have simply vanished. Instead, it may have been heated to incredible temperatures, millions of degrees, by the violent process of being torn away. Gas this hot doesn't glow in the familiar visible light our eyes can see. It radiates primarily in low-energy X-rays, forming a gigantic, diffuse, and incredibly faint halo that envelops the entire galaxy and blends into the even hotter plasma of the cluster itself. Our instruments are only just becoming sensitive enough to detect this extremely faint X-ray emission, and it's possible that a vast reservoir of the galaxy's normal mass is hiding in this form, a thin, superheated atmosphere that has been almost impossible to see until now. Another, more exotic possibility involves the transformation of matter itself. The turbulent environment around the central black hole and the regions of intense gravitational shear could be creating conditions where normal baryonic matter is converted into something else. Some speculative theories suggest that under such extreme pressures, quarks, the fundamental particles within protons and neutrons, could be deconfined, creating a strange soup of free-floating quark matter that would not interact with light in any recognizable way. Alternatively, the missing mass could be locked up in vast numbers of failed stars, black holes, neutron stars, or cold, planet-sized objects that litter the galactic halo but are far too dark and numerous for us to individually detect. Each of these explanations points to a universe where the simple categories of visible and invisible matter are far more complex and interconnected than we ever imagined, and where the most massive galaxies in the cosmos are still keeping fundamental secrets about their true composition. Moving outwards from the galaxy's core and into its wider gravitational domain, we encounter a cosmological puzzle that challenges our very understanding of the universe's expansion. This 17th phenomenon centers on the behavior of smaller satellite galaxies orbiting NGC 4889, specifically the light they emit. For nearly a century, astronomers have used redshift, the stretching of light waves towards the red end of the spectrum, as the primary evidence that our universe is expanding. The farther away a galaxy is, the faster it appears to be moving away from us, and the greater its redshift. This relationship, known as the Hubble flow, is the bedrock of modern cosmology. However, the galaxies circling this cosmic giant are not following the script. When their redshifts are meticulously measured, a significant number show values that are inconsistent with their estimated distances. Some exhibit far greater redshifts than the Hubble flow would predict, as if they are fleeing the area at inexplicably high velocities. Others show curiously diminished redshifts, implying they are moving much slower than expected or are even stationary relative to us. It's as if the smooth, predictable current of a river has encountered an invisible obstacle, creating chaotic eddies and whirlpools that defy the main flow. These anomalous redshift clusters indicate that powerful, unseen forces are at work, tugging and pulling on these galaxies in ways that overwhelm the general expansion of the universe itself. The most straightforward explanation points to the sheer gravitational might of NGC 4889 and the dense Coma Cluster it resides within. The collective pull from all this visible and dark matter could easily be accelerating some galaxies towards us while slinging others away at high speed, creating these peculiar motions. But when astronomers run the numbers, even the combined gravity of this immense structure struggles to account for the extreme velocities observed in some of these outliers. This discrepancy forces us to consider even more profound possibilities. Could the distribution of dark energy, the mysterious force driving the universe's accelerated expansion, be uneven or lumpy on these colossal scales? Our standard model assumes dark energy is a smooth, uniform property of space itself, but what if its strength varies from one region of the cosmos to another? A local concentration of stronger dark energy could provide an additional repulsive push, amplifying the redshifts of galaxies in that specific volume of space. Alternatively, we might be seeing the gravitational influence of structures so vast they lie beyond our current ability to map. The cosmic web is filamentary, with great walls of galaxies and immense voids. Perhaps NGC 4889 sits at the nexus of several such megastructures, and the gravitational tug from these unseen, larger-scale concentrations of mass, both dark and visible, is imparting these peculiar velocities to the smaller galaxies we can observe. Each anomalous redshift measurement is a clue, a piece of data suggesting that the serene, uniform expansion we've long taken for granted is far more complex and textured when viewed up close within the most massive structures in the universe. Streaming out from the depths of this galactic enigma comes a torrent of the universe's most energetic particles, a silent rain that bombards our atmosphere with forces we can scarcely comprehend. This 18th phenomenon reveals NGC 4889 as a cosmic ray factory of unprecedented power. Cosmic rays are not rays of light at all, but are instead atomic nuclei, mostly protons, that have been accelerated to nearly the speed of light. They are the universe's natural particle accelerators, but the ones originating from this galaxy are in a class of their own. These are ultra-high-energy cosmic rays, carrying kinetic energies millions of times greater than what the most powerful human-made collider, the Large Hadron Collider, can ever hope to produce. A single one of these subatomic bullets packs the punch of a professionally thrown fastball, all concentrated into a particle smaller than an atom. Discovering that this specific galaxy is a prime source for these particles was a staggering revelation. Our most sensitive observatories, like the Pierre Auger Observatory, which uses thousands of square kilometers of the Argentine desert as its detector, have traced the paths of these rare, ultra-high-energy particles back to their likely origin points. A statistically significant number of them point like celestial arrows back toward the Coma Cluster, and more specifically toward NGC 4889. This is no minor coincidence. It signifies that something within or around this galaxy is acting as a natural super collider, launching fundamental pieces of matter across the universe with unimaginable force. The central question, of course, is what cosmic engine could possibly achieve such phenomenal acceleration. The prime suspect is the galaxy's impossible supermassive black hole. While it may be dormant now in its active past, the chaotic maelstrom of its accretion disk and the powerful magnetic fields wound tight by its incredible rotation could have acted as a natural particle accelerator on a gargantuan scale. Protons and atomic nuclei caught in these intense magnetic whirlwinds could have been slingshotted around the black hole's event horizon over and over, gaining a little more energy with each pass until they were finally flung out into the void at near light speed. This process, akin to a gigantic cosmic ping-pong game with matter as the ball, could easily account for the immense energies we detect. However, the sheer power and consistency of the signal have led scientists to consider even more exotic possibilities. Could we be seeing the signature of dark matter annihilations? If dark matter is indeed made of particles, and if those particles are their own antimatter counterparts, then where they densely congregate, such as in those mysterious rings around the galaxy, they could be colliding and annihilating each other in a continuous, violent process. Such an event would not produce normal cosmic rays directly, but it would create a cascade of secondary particles and radiation, including high-energy protons and gamma rays, which could then be further accelerated by the galaxy's magnetic fields. This would make the entire dark matter halo a colossal, invisible engine of destruction, its energy output channeled into these incredibly energetic particles. There is a third, more recent theory that combines these ideas in a novel way. Some astrophysicists propose that the invisible jets we discussed earlier, those phantom outflows of energy, are the true culprit. If these jets are composed of a pure, incredibly intense beam of magnetic energy and fundamental particles, they could act as the universe's most powerful linear accelerator. A proton injected into the base of such a jet would be surfing a wave of pure force, accelerated along millions of light years in a perfectly straight line, all the while gaining energy until it reaches those mind-boggling levels we observe. Each ultra-high-energy cosmic ray that strikes our atmosphere is therefore a messenger, a tiny package of information delivered from one of the most extreme environments in the cosmos, telling a story of gravitational might, invisible matter, and forces that dwarf our greatest inventions. But the cosmic whispers from this distant galaxy are not limited to light and particles. They also resonate through the very fabric of space-time itself, bringing us to a 19th and profoundly fundamental mystery. Across the world, the incredibly sensitive detectors of the LIGO and Virgo observatories have been listening to the symphony of the universe, tuning into the ripples in reality known as gravitational waves. Most of the signals they pick up have a familiar, though awesome, signature: the accelerating chirp that signals the final, death spiral merger of two massive objects like black holes or neutron stars. It is a crescendo that climbs in frequency and amplitude before ending abruptly in a final ringdown. However, a handful of the most intriguing signals, traced back to the general vicinity of the Coma Cluster, do not follow this pattern at all. These waves, originating from the heart of NGC 4889, possess a bizarre and unique chirp signature. The frequency change is wrong, the amplitude is off, and the ringdown is either missing entirely or lasts for an unexpectedly long time. It's as if the cosmic orchestra is playing a note that doesn't exist on any known musical scale, a gravitational melody composed for instruments we have not yet discovered. These anomalous chirps are the unmistakable sound of something exotic, something that does not conform to the standard celestial cast of characters. The immediate and thrilling question is, what bizarre objects could be creating these impossible duets? The usual suspects of stellar mass black holes and neutron stars are ruled out by the very shape of the signal. This has propelled astronomers into the realm of theoretical physics to consider truly exotic possibilities. One compelling candidate is the hypothetical boson star. Unlike a normal star held together by nuclear fusion and gravity, a boson star would be a gigantic, diffuse object composed entirely of ultralight subatomic particles like actions, which are also a prime dark matter candidate. These particles would all occupy the same quantum state, forming a ghostly, wave-like structure that could be as massive as a black hole but without a sharp event horizon. The merger of two such objects would distort space-time in a uniquely soft, prolonged manner, potentially creating the strange, drawn-out chirp we detect, one that lacks the violent, definitive finale of a black hole collision. Another fascinating possibility involves primordial black holes. These are not the black holes formed from dying stars, but are theorized to have been forged directly from the extreme densities of the Big Bang itself. They could exist in a vast range of masses, from smaller than an atom to larger than a star. A binary system of two primordial black holes, especially if they are of an unusual mass not found in stellar evolution, could merge and produce a gravitational wave signal that deviates from the norm in both its timing and its tone. Furthermore, if these ancient relics make up a portion of the galaxy's dark matter, their interactions would be happening within the unique gravitational environment shaped by the central supermassive black hole, potentially amplifying or distorting their signals in ways we are only beginning to model. Each of these anomalous chirps is a direct message from the dark heart of the galaxy, a vibration that carries the fingerprint of objects that may have formed in the first second of the universe's existence. They challenge not only our catalogue of cosmic objects, but also our understanding of what matter can be and how gravity can behave under the most extreme conditions imaginable. At the very fringes of this cosmic giant, where the gravitational pull of its stars weakens and gives way to the emptiness of the intergalactic void, astronomers have mapped a structure that defies the very nature of cosmic gas. This 20th phenomenon is known as the hydrogen wall, a vast and startlingly coherent barrier of neutral hydrogen gas that envelops the galaxy like a colossal, invisible fortress. We're not talking about a loose, dissipating cloud. This is a sharply defined structure, a seemingly solid wall of primordial material that stretches across tens of thousands of light years, standing guard at the galactic frontier. The existence of such a structure is in itself a profound mystery. In the harsh environment of a dense galaxy cluster like Coma, the rules of survival are brutal. The space between galaxies is not a perfect vacuum. It is filled with a searingly hot plasma known as the intracluster medium. This superheated gas, which can reach temperatures of tens of millions of degrees, should act like a cosmic blowtorch, violently disrupting and evaporating any large, delicate cloud of cold neutral hydrogen. According to all our models, a cloud of this scale and density should have been torn apart, heated to oblivion, and assimilated into the cluster's diffuse plasma billions of years ago. The fact that it hasn't, that this hydrogen wall persists as a distinct and coherent entity, means that some unseen force is actively holding it together, protecting it from the hostile environment it calls home. So what could possibly be acting as the guardian of this cosmic rampart? The prime suspect is magnetism on an almost unimaginable scale. It's possible that the galaxy's powerful magnetic fields, which we know are complex and unusual from the monopole hunt, have been stretched and woven into a gigantic, galaxy-sized cage around this reservoir of gas. These magnetic field lines could be acting like a cosmic spider's web, providing a supporting structure that contains the hydrogen, preventing it from dispersing under its own pressure and shielding it from the eroding force of the hot intracluster wind. It would be like a delicate soap bubble miraculously holding its perfect spherical shape in the middle of a hurricane, its surface tension defying the chaos around it. Another fascinating possibility involves a dynamic equilibrium, a constant renewal process that maintains the wall against all odds. Perhaps the galaxy itself is continuously feeding this structure. The phantom jets pouring from its core, though invisible, could be channeling a steady flow of material out to these distant regions, replenishing the hydrogen as quickly as the intracluster medium strips it away. Alternatively, the wall might not be a static object at all, but the visible shock front of an ongoing collision between the galaxy's own extended gas halo and the broader flow of the cluster's plasma. In this scenario, the hydrogen wall is the cosmic equivalent of a wave constantly crashing against a rocky shore. It appears stable from a distance, but it is actually the product of a perpetual, violent struggle between two opposing forces. This immense structure is far more than a celestial curiosity. It is a protected reservoir of the universe's most primitive material. The hydrogen within this wall is likely largely unprocessed, a pristine relic from the early universe that has never been cycled through a star to be fused into heavier elements. Its very existence offers astronomers a rare opportunity to study the raw building blocks of galaxy formation in their original state, material that has been miraculously preserved for billions of years just outside one of the cosmos's most turbulent environments. The wall stands as a silent witness to the galaxy's long history, and its continued stability is a direct challenge to our understanding of physics on the largest scales, demonstrating that even in the most hostile corners of the universe, nature finds a way to create and maintain order. Surrounding this colossal galaxy, woven into the fabric of its immense magnetic field, are structures of trapped energy that dwarf anything in our own solar system. These are the phantom radiation belts, our 21st phenomenon, and they operate on a scale that challenges our understanding of particle physics. We are familiar with the concept here at home. Earth's Van Allen belts are donut-shaped regions where our planet's magnetic field captures and holds charged particles from the solar wind, creating a protective and dangerous zone of radiation. What we see around NGC 4889 is this same principle, but amplified to a literally galactic proportion. These are not mere belts. They are vast, dynamic reservoirs of energy, colossal structures that could engulf entire star clusters, filled with protons and electrons racing at near light speed. The mystery of these belts is not just their immense size, but their bizarre and unpredictable behavior. Their intensity does not remain constant. Instead, it fluctuates wildly and rapidly, with the radiation levels surging and fading in cycles that have no apparent correlation with any known celestial clock. It's as if a giant, invisible hand is randomly turning a cosmic dimmer switch up and down for these particle accelerators. One week, a belt might be relatively calm. The next, it could be raging with an intensity that would instantly sterilize any world within its boundaries. This erratic pulsation is the central puzzle. On Earth, the Van Allen belts respond predictably to the sun's activity, flaring up during solar storms and settling during quieter periods. Here, the changes seem to originate from within the galaxy itself, disconnected from any obvious external trigger. So what invisible force is governing this chaotic dance of energy? The first and most likely culprit is the galaxy's own mysterious and tumultuous magnetic field. We know from our search for monopoles that this field is complex and potentially fractured, with lines that may snap and reconnect in violent events known as magnetic reconnection. This process is a powerful particle accelerator, and if it is happening on a galactic scale within these belts, it could easily account for the sudden, violent surges in radiation. The phantom jets erupting from the core could also be playing a role, periodically injecting fresh waves of high-energy particles into these magnetic traps, flooding them with new fuel in unpredictable bursts. A more speculative, yet utterly fascinating, theory involves the possibility of unseen planetary systems on a truly grand scale. Imagine not a single star with a family of planets, but a vast population of rogue planets, worlds flung from their birth stars, now drifting freely through the galactic halo. If even a small percentage of these dark, nomadic worlds possessed strong magnetic fields of their own, their movement through the galaxy's overarching magnetic environment could create localized disturbances. As these unseen planets plowed through the radiation belts, their own magnetospheres could interact with the larger field, creating shock waves and turbulence that trigger the intense fluctuations we detect. It would be like watching a still pond suddenly erupt with ripples and not being able to see the stones being thrown in. We would be witnessing the effects of a hidden population of worlds, their presence betrayed only by the chaotic waves they stir up in this sea of radiation. These phantom belts are therefore more than just a deadly cosmic weather system. They are a sensitive instrument, their fluctuations recording the activity of forces and objects we cannot yet see, painting a picture of a dynamic and violently alive galactic environment. Deep within the searing heart of the galaxy, where gravity warps reality and densities reach impossible extremes, we encounter a phenomenon that challenges the boundary between the quantum world and our own. This is the 22nd great mystery of NGC 4889, evidence of quantum tunneling events occurring on a scale so vast it defies every classical law of physics. To understand the sheer weirdness of this, we need to simplify a bizarre quantum concept. In our everyday classical world, if you roll a ball towards a hill, it needs enough energy to get over the top to reach the other side. If it doesn't have that energy, it simply rolls back. In the subatomic quantum realm, the rules are different. A particle like an electron faced with an energy barrier it cannot classically overcome doesn't always bounce back. There's a finite, calculable probability that it will simply appear on the other side. It doesn't go over the barrier, it effectively teleports through it, a process physicists call quantum tunneling. This isn't science fiction. It's a well-documented phenomenon that is crucial to nuclear fusion in stars like our Sun, and is the operating principle behind modern electronics like flash memory and scanning tunneling microscopes. The baffling observations from this galaxy's core suggest that this quintessentially tiny, probabilistic event is not staying in its lane. It appears to be scaling up, happening on a macroscopic level, involving vast amounts of energy and matter in a way that should be statistically impossible. The telltale signature is an anomalous and incredibly efficient transfer of energy from the inner accretion disk of the supermassive black hole to the surrounding plasma. The temperatures and energy states we detect in the hot gas just outside the event horizon are precisely what they should be if a portion of the energy simply bypassed the intense gravitational and magnetic barriers that, according to classical physics, should have contained it. It's as if the intense heat from a furnace was somehow appearing outside the heavily insulated room that contains it without ever having passed through the walls. The energy arrives where it shouldn't be, as if it took a shortcut through the very fabric of space-time itself. The implications of this for stellar processes and black hole thermodynamics are nothing short of revolutionary. If macroscopic quantum tunneling is indeed a viable process in such an extreme environment, it could rewrite our understanding of how black holes feed and grow. The standard model of accretion involves matter gradually spiraling inward, losing energy through friction and magnetic braking before finally crossing the event horizon. But if tunneling allows energy and even matter to effectively bypass parts of this chaotic journey, it would mean black holes could regulate their own growth and energy output in ways we never anticipated. This could provide a missing piece to the puzzle of why the galaxy's central black hole is so impossibly massive, yet its surroundings are so deceptively calm. Perhaps tunneling acts as a pressure release valve, preventing a catastrophic buildup of energy that would otherwise tear the galactic center apart. Furthermore, this challenges the very foundations of black hole thermodynamics, a field that uses the laws of heat and energy to describe these gravitational monsters. Stephen Hawking's work showed that black holes have temperature and entropy, properties deeply connected to quantum mechanics. The potential observation of large-scale tunneling in NGC 4889 suggests that the quantum effects governing a black hole's behavior are not confined to the microscopic realm of virtual particles at its event horizon, but may be active and dominant throughout its entire feeding process. This galaxy might be showing us that in the most gravity-dominated regions of the universe, the quantum world doesn't just influence reality. It becomes reality, governing the flow of energy and matter on a cosmic scale with a spooky, probabilistic hand. Now we turn to a paradox so profound it threatens to unravel the cosmic timeline itself, nestled within the very stars that light this galactic giant. Scattered throughout NGC 4889 are ancient suns that, according to our most reliable models of stellar evolution, simply should not exist. These are the impossibly old stars, and their calculated ages present us with a glaring chronological inconsistency that cuts to the very heart of cosmology. By analyzing the light from these stars, astronomers can determine their chemical composition with incredible precision. The oldest stars are metal-poor, meaning they contain very low amounts of elements heavier than hydrogen and helium. This is because they formed early in the universe's history, before generations of supernova had seeded space with the forged elements of stellar cores. The specific mix of elements and the star's current stage of life allows scientists to estimate its age with remarkable confidence. For several stars in this galaxy, that estimated age comes out to be greater than the current estimated age of the entire universe, 13.8 billion years. It's the astronomical equivalent of finding a birth certificate for a person who is 100 years old in a town that was only founded 90 years ago. This age paradox forces a rigorous re-examination of our assumptions from multiple angles. The first and most conservative explanation is, of course, a monumental error in our measurements. Determining the distance to a star in another galaxy is an immensely complex process, and a small error in distance can lead to a significant error in calculating its intrinsic brightness, which is a key component in estimating its age. Alternatively, our models of how stars burn their fuel and evolve might be incomplete, especially for stars that formed in an environment as unique and primordial as that of an ancient elliptical galaxy. Perhaps the initial composition of these stars was so peculiar, lacking certain key elements that act as catalysts or inhibitors in nuclear fusion, that they age at a radically different rate than the stars we have studied in our own galactic neighborhood. Yet, if repeated observations and refined models continue to point to this impossible age, we are left with far more thrilling possibilities. One compelling theory suggests that these stars are not actually older than the universe, but are instead relics from a previous cosmic cycle. Some cosmological models, like the conformal cyclic cosmology proposed by physicist Roger Penrose, suggest that our universe might be just one in a series, with a new Big Bang emerging from the end of a previous eon. In this model, information and structure could somehow be transmitted from one cycle to the next. These impossibly old stars could therefore be cosmic survivors, their fundamental structure somehow preserved across the end of one universe and the birth of our own, making them truly older than the time since our Big Bang. Another, less dramatic but equally mind-bending, idea connects back to the galaxy's unique gravitational environment. We have already discussed the profound time dilation effects caused by its immense mass. What if these particular ancient stars are orbiting deep within one of those gravitational hotspots, where time flows far more slowly relative to the rest of the cosmos? From our remote perspective, the star would appear to have aged very little over the billions of years we have been observing it, artificially inflating our estimate of its true age. Its clock has literally been ticking slower, making it appear ancient and unchanged in a way that contradicts the universal timeline we experience. Each of these stellar ancients is a silent witness, its light forcing us to question whether our cosmic calendar is complete, or if the universe holds secrets about its own origin that we are only just beginning to perceive. But our exploration takes an even more profound turn as we consider the galaxy's place in the cosmos at the very largest scales, a discovery that hints at influences from realms beyond our ability to observe. This 24th phenomenon connects NGC 4889 to one of the most controversial and mind-bending concepts in modern cosmology, the dark flow. For decades, the cornerstone of our cosmological model has been the principle that the universe is homogeneous and isotropic on the largest scales. This means that, on average, it should look the same in every direction, and that the motion of galaxies should be entirely governed by the uniform expansion of space, known as the Hubble flow, with any minor deviations being random and local. However, careful studies of the motion of entire galaxy clusters, including our own Coma Cluster, have revealed a startling anomaly. These massive structures are not all moving in random, gentle drifts as expected. Instead, a significant number, including the cluster containing NGC 4889, appear to be drifting in a coherent stream, all pulled toward a single, specific point in the sky near the constellations of Centaurus and Vela. This is not a flow caused by the expansion of the universe. It is a peculiar velocity, a directed motion superimposed on the cosmic expansion, as if a vast, unseen hand is gently tugging these clusters in a preferred direction. The sheer scale of this motion is what earns it the name dark flow, and its very existence challenges the cosmological principle itself. The connection of NGC 4889 to this phenomenon is particularly significant because of its immense mass. As one of the most massive galaxies in one of these drifting clusters, it acts as a precise cosmic anchor point, its motion providing a key data point in mapping the extent and direction of this mysterious current. The fact that such a colossal object is part of this coordinated movement suggests the force behind it is unimaginably powerful, capable of influencing the motion of structures containing thousands of galaxies. So what could possibly be exerting such a gravitational pull on the entire Coma Cluster? The most straightforward explanation within our standard model would be an incredibly massive supercluster of galaxies that we simply haven't mapped yet, a great attractor on a scale far grander than anything we've found. Yet, even the known great walls of galaxies seem insufficient to account for the strength and coherence of the dark flow. This failure of conventional explanations opens the door to possibilities that lie beyond the current frontiers of physics and cosmology. The most thrilling and contentious theory is that the dark flow is evidence of a gravitational influence from a region of space-time that is completely outside our observable universe. Our cosmic horizon, the limit of what we can see, is set by the distance light has traveled since the Big Bang, but the universe itself is almost certainly much larger than this observable bubble. The dark flow could be the gravitational echo of a massive structure, perhaps another universe in a vast multiverse, or an immensely dense region of our own universe that inflated to a different rate during the Big Bang, that lies beyond our horizon, its immense gravity subtly tugging on everything within our field of view. For NGC 4889 to be caught in this flow means we are not looking at an isolated island universe, but are instead part of a much larger and utterly mysterious cosmic architecture whose full extent remains hidden from us. This galaxy's silent drift through the void may be the first clue that our universe is not alone. Yet another layer of this galaxy's mystery reveals itself not in what is present, but in what is violently and paradoxically absent, a phenomenon of pure annihilation that illuminates the darkness. Streaming from the very heart of NGC 4889 is a colossal fountain of the universe's most elusive and dangerous substance, antimatter. This is not a mere trickle, it is a geyser of particles that are the mirror opposites of normal matter, erupting from the galactic core and flowing out into the void. We cannot see this antimatter river directly, for it is as dark as the vacuum it moves through. Instead, we detect its existence by witnessing its spectacular and final demise. When a particle of antimatter, such as an antiproton, meets its normal matter counterpart, they annihilate each other in a flash of pure energy, converting their entire mass into intense gamma-ray radiation. It is this telltale, furious glow of gamma rays that maps out the antimatter fountain's path, tracing a brilliant, deadly river of light against the darkness, a constant fireworks display of mutual destruction on a cosmic scale. The sheer volume of antimatter required to sustain such a continuous fountain is staggering, and its very existence presents a monumental puzzle for physicists. In our current understanding of the universe, antimatter is incredibly rare. The Big Bang should have created equal amounts of matter and antimatter, yet somehow, almost all of the antimatter was lost, leaving behind the material universe we see today. Finding a natural source that generates antimatter in such vast quantities forces us to reconsider where and how this exotic substance can be created. So what cosmic engine at the center of this galaxy is acting as a factory for the universe's most volatile product? The prime suspect is once again the unimaginable environment surrounding the supermassive black hole. The intense gravitational and magnetic fields near the event horizon can accelerate particles to near light speed. In this maelstrom of energy, pairs of particles and antiparticles can spontaneously blink into existence from the pure energy of the vacuum itself, a process predicted by quantum field theory. Normally, these particle-antiparticle pairs would almost instantly recombine and annihilate. However, the complex physics of the black hole's accretion disk and its powerful jets might be providing an escape route. It's theorized that the magnetic fields could act as a sort of cosmic sorting mechanism, funneling the newly born antimatter particles in one direction and the normal matter in another, effectively separating them before they can destroy each other. This segregated antimatter could then be launched outwards in the phantom jets, creating the sustained fountain we observe. An even more exotic possibility involves the galaxy's abundant dark matter. Certain theoretical models propose that dark matter particles are not completely stable. They could be their own antiparticles. If this is true, then where dark matter particles densely congregate, such as in those mysterious rings around the galaxy, they could occasionally collide and annihilate each other. This annihilation would not produce normal gamma rays directly, but it could generate a secondary shower of particles that includes a significant fraction of antimatter. This antimatter would then be accelerated by the galaxy's magnetic fields, feeding the fountain from a hidden, dark reservoir. The gamma rays we see would therefore be a secondary signature, the final flash of a chain reaction that began with the invisible decay of the universe's most mysterious substance. This antimatter fountain is more than a spectacular light show. It is a direct probe into the most extreme particle physics occurring in nature's most powerful laboratory. Each gamma-ray photon carries information about the process that created its antimatter source, offering clues about the behavior of matter and energy under conditions we could never hope to replicate on Earth. It stands as a violent testament to the fact that even in the apparent stillness of a giant elliptical galaxy, the fundamental battle between matter and antimatter is still being waged, a perpetual war of creation and destruction happening on a scale that dwarfs human imagination. Yet the gravitational strangeness of this galaxy extends beyond its dark matter rings and into the very way it bends the fabric of the cosmos, creating a lensing effect so peculiar it has sparked a fiery debate at the very foundation of modern physics. When astronomers use NGC 4889 as a natural telescope to peer at even more distant galaxies, they rely on the predictable laws of general relativity. The immense mass of the galaxy should warp the space around it, bending the light from background objects in a specific, calculable way to create magnified and often multiple images. But time and again, the lensing effects observed here defy those clean calculations. The resulting images are sometimes far too bright, as if an invisible hand has turned up a cosmic dimmer switch, or they are twisted into arc-like shapes that are more distorted than any standard model of the galaxy's mass distribution can account for. It's like looking at your reflection in a funhouse mirror and seeing a distortion that doesn't match the mirror's shape, suggesting there's something hidden behind the glass warping your image even further. These gravitational lensing anomalies present scientists with a stark and consequential choice, forcing a debate that cuts to the very core of our understanding of the universe. The prevailing explanation, championed by most astrophysicists, invokes the presence of additional, unseen mass. This could take the form of countless small, dark objects within the galaxy's halo, a vast population of primordial black holes, cold rogue planets, or dense knots of dark matter that our telescopes cannot directly image. These hidden masses would act as tiny additional lenses within the Great Lens, their combined gravitational influence amplifying the light and twisting the images beyond what the smooth distribution of the main halo would produce. Each anomalous brightening is seen as a footprint, a direct signal of this shadow population of dark matter clumps. However, a dedicated group of physicists sees these very same anomalies not as evidence for hidden mass, but as proof that our theory of gravity itself is incomplete. They propose modified Newtonian dynamics, or MUND, and its relativistic extensions. This controversial framework suggests that on the immense scales of galaxies, the force of gravity does not weaken as quickly as Newton's or Einstein's laws predict. In this view, there is no missing dark matter. Instead, the stronger-than-expected lensing is a direct result of gravity itself being stronger over these vast distances, eliminating the need for any invisible substance. The distorted images are not clues to hidden mass, but are instead the first clear glimpses of a new law of physics, a modification to Einstein's masterpiece that only reveals itself in the weakest gravitational fields found in galactic halos. The lensing effects from NGC 4889 have become a crucial battleground in this decades-long debate. The galaxy's immense mass and complex structure make it an ideal testing ground. Proponents of dark matter point to the ring-like structures already discovered as evidence that their model is flexible enough to accommodate these anomalies, simply requiring more detailed maps of how dark matter is clustered. MUND advocates, however, argue that the specific patterns of distortion match their predictions more cleanly than the constantly revised dark matter models. This isn't just an academic argument, it is a struggle over the fundamental architecture of the cosmos. Is the universe primarily made of stuff we cannot see, or are we on the verge of a paradigm shift in our understanding of one of nature's most fundamental forces? Each strangely bent ray of light passing through this galactic giant carries the weight of that question, its path holding the potential to confirm our current model or guide us toward a revolutionary new one. But our journey through the anomalies of NGC 4889 now takes us from the heart of the galaxy to the very edge of the observable universe itself, connecting this cosmic giant to one of the most enduring mysteries in all of cosmology. This 27th phenomenon links the galaxy to the famous cosmic microwave background cold spot, a colossal and perplexing region of space that appears to be a chilling void in the universe's oldest light. The cosmic microwave background, or CMB, is the faint afterglow of the Big Bang, a nearly uniform blanket of microwave radiation that fills every direction of the sky. It is the oldest light we can see, a baby picture of the cosmos when it was just 380,000 years old. While this background is remarkably even, it is not perfectly smooth. Tiny fluctuations in temperature on the order of 1/100,000th of a degree reveal the seeds that would eventually grow into galaxies and clusters. Yet one anomaly stands out dramatically: the Eridanus supervoid, a region so disproportionately cold it has baffled scientists for nearly 2 decades. This cold spot is a vast circular patch in the sky about 5 degrees across, where the CMB temperature is significantly lower than the surrounding average. For scale, that's about 10 times the diameter of the full moon. This isn't a tiny statistical blip. It is a massive and unexpected feature in the universe's most fundamental map. The prevailing theory to explain this deep freeze involves the concept of a supervoid. The idea is that if a truly enormous region of space exists with a much lower density of galaxies and matter than average, photons from the CMB could lose energy as they travel through it. This happens through a subtle effect called the integrated Sachs-Wolf effect. As a photon enters a gravitational well, it gains energy, blue-shifting slightly. As it exits, it loses energy, redshifting. In a universe dominated by matter, these effects would cancel each other out. However, in our dark energy-dominated universe, the gravitational potential of a void is not static. It weakens over time as the void expands. This means a photon exiting the void loses more energy than it gained entering it, resulting in a net energy loss and thus a cooler temperature in the CMB radiation coming from that direction. The cold spot, therefore, could be the shadow cast by the largest known structure of nothingness in the universe. So, where does NGC 4889 fit into this puzzle? Its position is the first tantalizing clue. The galaxy resides in the Coma Cluster, which lies in the general direction of the cold spot. While not directly in the center of the anomaly, its location within this vast celestial neighborhood makes it a key piece of the cosmic architecture in this sector of space. As one of the most massive gravitational anchors in the region, its presence and influence are critical to mapping the true large-scale structure here. The question astronomers are urgently trying to answer is whether NGC 4889 and the entire Coma Cluster are part of the outer fringe of this proposed supervoid, acting as a dense wall bordering an immense emptiness, or if they are situated within a vast, underdense filament that connects to the void itself. Its immense gravity could be subtly distorting our view of the void's true shape and size. The properties of this galaxy add even more fascinating layers to the mystery. We have already explored its missing baryons and the possibility of immense, faint halos of hot gas. If such a tenuous, superheated atmosphere extends far beyond the visible galaxy, it could have a previously unconsidered effect on photons passing through it, potentially contributing to the cooling mechanism. Furthermore, the galaxy's complex gravitational field, warped by its impossible black hole and dark matter rings, could act as a secondary lens, subtly altering the path of CMB photons in a way that enhances the cold spot signature from our perspective. It might not be the sole cause, but it could be a contributing factor that makes the anomaly appear more severe than it truly is. However, the plot thickens considerably because the supervoid explanation itself is hotly debated. Some detailed surveys have struggled to find a void large and empty enough to account for the extreme temperature drop observed. This failure has led to more exotic proposals, and once again, NGC 4889's bizarre phenomena make it a candidate for a far more radical explanation. Some cosmologists have suggested the cold spot could be evidence of a collision with a parallel universe in the multiverse scenario. While this remains highly speculative, the other quantum anomalies we've seen in this galaxy, from potential large-scale entanglement to the stirring of quantum foam, make it a fascinating focal point for such wild ideas. Could the galaxy's strange quantum signatures be a local manifestation of a much larger, universal boundary issue? Is it a cosmic beacon, marking a place where the fabric of our reality was once stretched thin by a monumental collision with another cosmos? While this remains firmly in the realm of theoretical physics, the mere possibility illustrates how NGC 4889 sits at the crossroads of multiple cosmic mysteries. Its immense gravity pulling together not just stars and dust, but the very threads of our understanding of the universe's largest scales and deepest laws. Perhaps the most profound and speculative of all the mysteries surrounding this galaxy is the idea that its immense interconnected structures might mirror something eerily familiar: the neural networks of a conscious brain. This is not to suggest the galaxy is literally thinking, but rather that the sheer complexity of its phenomena, from the web-like dark matter rings to the synchronized yet chaotic pulses of its neutron stars and the vast, information-rich magnetic fields, presents a pattern of organization that, on a purely structural level, echoes the connectivity within a mind. The galaxy functions as a single, dynamic system, with energy, information, and forces flowing through it in a continuous feedback loop, much like electrical signals dance across a biological brain's synapses. This visual and mathematical resemblance has led a small group of physicists and philosophers to entertain a breathtakingly far-out hypothesis known as the quantum consciousness hypothesis on a galactic scale. The theory speculates that under the right conditions of extreme complexity and connectivity, a form of awareness could potentially emerge from any sufficiently intricate system, even one made of stars, dark matter, and plasma. In this view, the 30 strange phenomena might not be isolated puzzles but interacting components of a single, vast, and incomprehensibly slow cosmic process, a dim, galaxy-sized flicker of something that could be misinterpreted as thought. It is absolutely vital, however, to approach this idea with a heavy dose of scientific skepticism. The leap from observing complex, self-organizing patterns to claiming the existence of consciousness is a monumental one, and it currently resides firmly in the realm of metaphysical speculation rather than empirical science. There is no mechanism we know of that would allow for consciousness to arise from gravitational interactions and nuclear fusion, nor any way to test for its presence across light years of space. What we are truly observing are the awe-inspiring emergent properties of physics operating at a scale we are only beginning to understand. The patterns that inspire these thoughts are natural phenomena: the gravitational choreography that forms galactic filaments, the magnetic dynamos that accelerate particles, and the quantum laws that govern the behavior of matter at its most fundamental level. These processes create structures of stunning complexity that can, to our pattern-seeking human brains, appear designed or even alive. This says more about our innate desire to find familiar shapes in the chaos of nature than it does about the actual nature of the galaxy itself. The true value of this hypothesis is not in its literal interpretation, but in its power to stretch our imagination and force us to confront the sheer, otherworldly complexity of the cosmos. It challenges us to define what we mean by complexity and information processing in an entirely new context, pushing the boundaries of both physics and philosophy. So while NGC 4889 is almost certainly not a conscious entity, its bizarre and interconnected behavior forces us to wonder if the universe possesses a capacity for organization so profound that it continually blurs the line between the physical and the almost metaphysical. And now we arrive at a concept so strange it seems to challenge the very idea of what a particle is, forcing us to consider that the building blocks of reality might not be blocks at all. This is the 29th phenomenon, the hunt for unparticle signatures within the energy flows of NGC 4889. To grasp just how bizarre this idea is, we need to understand the standard model of particle physics, which has been our guide to the universe's ingredients for decades. In this model, everything is made of particles: electrons, quarks, photons, each with well-defined properties like mass, charge, and spin. They are the discrete, countable Lego bricks of existence. Unparticles, a theoretical proposal from physicist Howard Georgi, throw that entire rulebook out the window. They are not particles in any conventional sense. Instead, they are thought to be the manifestation of a hidden sector of reality, a realm with entirely different rules where scale and dimension operate unlike anything we know. An unparticle does not have a specific mass. It behaves more like a continuous field or a strange, ethereal substance that doesn't fit into the neat categories of the standard model. Its most defining characteristic is how it interacts with energy. When a conventional particle is involved in a collision or decay, the energy involved is distributed in a very specific, quantized way, like money being exchanged in specific denominations. But processes involving unparticles would show a smooth, continuous spectrum of energy distribution, as if the energy were being divided not into coins and bills, but into a continuous flow of gold dust. So why would we look for such an exotic signature in this particular galaxy? The answer lies in the most head-scratching energy readings coming from its core. When astronomers analyze the high-energy radiation, the X-rays and gamma rays emanating from the region around the supermassive black hole, they find a persistent and puzzling smoothness in the energy distributions. There are features in the spectra that lack the sharp, discrete spikes we would expect from known atomic transitions or particle interactions. It's as if the energy is being processed through a cosmic blender that erases all the sharp edges, leaving behind a strangely featureless, continuous hum. This anomalous smoothness is the exact kind of fingerprint that theorists predict unparticle interactions would leave on the universe. The immense gravitational and magnetic forces at work in NGC 4889 provide a unique environment where such exotic physics could be revealed. The black hole's accretion disk is a cauldron of unimaginable energy, a place where the vacuum of space itself is thought to churn with quantum activity. It is precisely the kind of extreme laboratory where the hidden sectors of reality might briefly connect with our own, allowing unparticle stuff to influence the behavior of energy and matter in ways that become visible to our telescopes. The galaxy's other mysteries, like its impossible stability and strange jets, could all be pieces of a larger puzzle that points toward physics beyond the standard model, with unparticles acting as a possible unifying thread. However, the challenge in confirming this is monumental. The signatures are subtle and buried within a storm of other radiation. Teasing out the smooth signal of a potential unparticle interaction from the background noise of conventional astrophysical processes requires a level of precision that pushes our current instruments to their absolute limits. It demands not just more data, but entirely new ways of analyzing the data we have, searching for statistical ghosts in the machine. Furthermore, any potential discovery would have to withstand the relentless scrutiny of the scientific community, which will rightly demand that every single conventional explanation, from unknown plasma physics to peculiar chemical compositions, is exhaustively ruled out before we can even begin to entertain such a revolutionary idea. The search for unparticles is a gamble on the farthest frontiers of physics, a bet that the greatest anomalies in the cosmos can only be explained by its most speculative and beautiful ideas. Yet the gravitational influence shaping this galaxy extends far beyond its own borders, weaving it into a tapestry of motion on the most colossal scale imaginable, a phenomenon that places it directly in the path of one of cosmology's most enduring mysteries. This brings us to our 30th and final strange phenomenon, the profound connection between NGC 4889 and the enigmatic Great Attractor. For decades, astronomers have mapped the peculiar velocities of galaxies, their motions above and beyond the uniform expansion of the universe. A startling pattern emerged: our own Milky Way, along with our entire local group of galaxies and even the immense Virgo cluster, are all being pulled in a specific direction toward a point in the sky near the constellations Norma and Centaurus. This mysterious, unseen source of gravitational pull has been named the Great Attractor, and its influence spans hundreds of millions of light-years, orchestrating the motion of countless galaxies in a vast cosmic river flow. The sheer scale of this motion indicates the Great Attractor must be unimaginably massive, a concentration of matter so huge it should be visible as the most brilliant structure in the sky. Yet when we look in that direction, our view is severely obscured. It lies directly behind the plane of our own Milky Way, hidden by the thick veil of stars, gas, and dust that constitutes the galactic bulge, a region so dense we call it the zone of avoidance. It is the universe's greatest magic trick, an elephant hiding directly behind a lamppost. For a long time, the true nature of this gravitational behemoth remained speculative. This is where NGC 4889 becomes a crucial celestial signpost. Its position within the Coma Cluster places it much farther along this cosmic current, closer to the suspected source of the pull. It is not merely another piece of driftwood caught in the flow. Its immense mass means it is a major player, a gravitational anchor point that itself influences the motion of other galaxies within this vast stream. By studying its precise movement and the subtle ways it tugs on the space around it, astronomers can triangulate the true source and strength of the force pulling it. The galaxy acts as a probe, its trajectory a plotted line pointing directly back to the heart of the mystery. Its impossible stability and complex dark matter structures might even be influenced by this constant, immense tidal force, as if the entire galaxy is being subtly stretched and shaped by an invisible hand. Recent observations have begun to pierce the veil of dust, revealing that the Great Attractor is likely not a single, monolithic object but the core of a colossal supercluster of galaxies, now known as the Laniakea supercluster, of which our own local group is merely a distant suburb. Yet, even this immense structure seems insufficient to account for the full strength of the observed flow. This suggests that the Great Attractor itself may be moving, pulled by something even larger and more distant lurking in the darkness beyond. NGC 4889, therefore, might be caught in a cascade of gravitational influences, a whisper of a force that originates from a structure so vast it redefines our understanding of the cosmic web. Its silent journey through the void is a key to mapping not just one anomaly, but an entire hierarchy of invisible mass that governs the motion of the universe on the grandest of scales. From the impossible black hole anchoring its core to the faint whispers of potential unparticle interactions within its energetic heart, the 30 strange phenomena of NGC 4889 present a tapestry of cosmic mysteries so rich it challenges the very pillars of modern physics. We have journeyed through a realm where time flows at different rates in neighboring pockets of space, where dark matter coalesces into impossible rings, and where the universe itself might be communicating through quantum entanglement on a scale once thought unimaginable. We've encountered singing neutron stars, phantom jets of invisible energy, and the haunting possibility that we are witnessing the echoes of stellar deaths for which we have no classification. Each anomaly, from the missing baryons to the antimatter fountain and the galaxy's role in the dark flow, is not an isolated curiosity but a single thread in a much larger, interconnected enigma. This colossal galaxy has emerged not merely as a collection of stars, but as the universe's ultimate natural laboratory. Its immense scale and extreme environment provide a unique testing ground where the laws of physics are stretched to their absolute limits, revealing cracks in our understanding and hinting at profound new principles waiting to be discovered. The observations pouring in from this distant island universe are actively forcing scientists to reconsider long-held theories about gravity, matter, and the very fabric of space-time. It serves as a powerful reminder that our models, no matter how elegant, are only approximations of a reality far more complex and wondrous than we have yet conceived. The greatest breakthroughs in our understanding of the cosmos often come from the places where our predictions break down, and NGC 4889 is a veritable factory of such glorious, mind-bending failures. Unlocking these secrets demands a relentless pursuit of knowledge, combining ever more precise observations with bold theoretical innovation. Each new generation of telescopes, from immense ground-based observatories to space-based instruments peering across the electromagnetic spectrum, brings us closer to resolving these mysteries. Yet the hardware is only part of the equation. It is the human capacity for curiosity and creativity that will ultimately piece this puzzle together. Theorists must be courageous, willing to venture beyond the comfortable confines of established science to imagine new forms of matter, new dimensions, and new forces that can account for the bewildering data. The story of this galaxy is still being written, and it invites all of us to participate in a grand, collaborative effort to decode the universe. As we conclude this journey into one of space's greatest enigmas, we turn the question over to you. Which of these 30 phenomena captivates your imagination the most? Does the philosophical shock of macroscopic quantum entanglement intrigue you, or does the raw power of the ultra-high-energy cosmic ray factory leave you in awe? Perhaps the eerie infrared geometries or the timeless age of its oldest stars spark your curiosity. Share your thoughts in the comments below. We are endlessly fascinated by which mysteries resonate most deeply with fellow explorers of the cosmos. Your perspective is a vital part of this ongoing conversation, a reminder that the wonder of discovery is an experience we all share.